Hello students, before starting fundamental theorem of arithmetic, let us know about even and odd numbers as well as prime and composite numbers. First, as you know that even numbers are those numbers which are divisible by 2, whereas the numbers which are not divisible by 2 are called odd numbers. For example, the numbers 2, 4, 6, 10, 50, 90, 100, 500, etc. are even numbers, as these all are divisible by 2. On the other hand, the numbers 1, 3, 5, 7, 9, 11, etc. are odd numbers, as they are not divisible by 2. Prime and composite numbers. The numbers which have only two factors, that is the number 1 and the number itself, are called prime numbers. On the other hand, the numbers which have more than two factors are called composite numbers. For example, the numbers 2, 3, 5, 7, 11, 13, 17, etc. are all prime numbers because they have only two factors, the number 1 and the number itself. Whereas the numbers 4, 6, 8, 9, 10, 12, 15, 16 are all composite numbers because they have more than two factors. For example, 4 is divisible by 1, 2 and 4, having three factors, more than two factors. In the same way, the number 6 is divisible by 1, 2, 3 and 6. Thus it has four factors. The number 9 is divisible by 1, 3 and 9. This shows that the number 9 has three factors, 1, 3 and 9. That is, it has more than two factors, so 9 is a composite number. Here we should note that 1 is neither taken as prime nor composite. Now we shall discuss about fundamental theorem of arithmetic. What does this theorem state? It states that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which prime factor occur. For example, the number 6 can be expressed as 2 into 3 or 3 into 2. This implies that this composite number has only two prime factors, and these factors are unique. No other number, no other prime number it will have in its prime factorization. In the same way, the number 231 can be expressed as 3 into 7 into 11 or 7 into 3 into 11 or 11 into 3 into 7. All these prime factorization shows that the number 231 has only 3 factors, namely 3, 7 and 11, no matter in which order they occur. Now we shall take question number 1 of exercise 1.2 of NCERT math books, in which we shall use this fundamental theorem of arithmetic. The question is, express 140 and 3825 as a product of its prime factors. So the number 140 can be factorized by taking prime number like this. In this way, 140 can be expressed as 2 power 2 into 5 into 7, as there are 2 2's, 1 5 and 1 7 in its prime factorization. So this is the expression of 140. In the same way, 3825 can be expressed as 3 power 2 because there are 2 3's, 5 power 2 and 17. Now we shall find out the HCF and LCM using fundamental theorem of arithmetic, that is prime factorization method. Question number 2, exercise 1.2. HCF of 26 and 91. 26 can be factorized as 2 into 13 and 91 as 7 into 13. So highest common factor of 26 and 91 is 13 because 13 is common in both the lines. In HCF, we take common factors and multiply them. How to find the LCM of 26 and 91? 26 and 91 factorized in the same manner as in case of HCF. Now in this case, we take factors of all variety with maximum occurrence, that is with maximum power. So LCM of 26 and 91 is 2 into 7 into 13 because there are factors of 3 variety, either 2 or 7 or 13, and 2 is only once in first line, so it is maximum. 7 is once and 13 is also one time in both the lines. So LCM is 2 into 7 into 13, which is equal to 182. Now verification of the property that LCM and HCF of two numbers product of the LCM and HCF of two numbers is always equal to their product. So here LCM of 26 and 91 is 182 and HCF is 13. So their product is 2366, and here the product of these two numbers is also 2366. This shows that LCM of 26 into 91 multiplied HCF of these two numbers is equal to product of these two numbers. This is the property only for two numbers. Question number 3. Now we will find out the LCM and HCF of more than two numbers. Here we have to find the LCM and HCF of 12, 15 and 21. So factorize 12, 15 and 21 as shown here. Then LCM is equal to 2 into 3 into 5 into 7. That is, we have taken factors of all variety. Since 2 is maximum times here, so we will raise the power 2 of this 2, and other numbers are only ones, so their product is 420. In HCF we take the common factor, which is 3 here, because 3 occurs in first, second and third line. Here common factor is only 3. Here we should note that if nothing is common, then HCF becomes 1. Let us take question number 4 of the exercise 1.2. Given that HCF of 306 and 657 is 9, find the LCM of these two numbers. As we know, the relation between the HCF and LCM of two numbers, which is HCF of AB into LCM of AB is equal to A into B. Here HCF of these two numbers is 9, so we put 9 here. And to find the LCM of these two numbers, so we write LCM of these two numbers, which is to be found out. And these two numbers are 306 and 657, so A into B is 306 into 657. So LCM of these two numbers will be 306 into 657 by 9, which gives 22,338. Come to the question number 5. The question is like this: check whether 6 power n can end with the digit 0 for any natural number n. Here we shall use the fact that the number ending in 0 is always divisible by 5, like 10, 20, 30, 100. These all numbers are divisible by 5. Using this fact, we will find out whether 6 power n can end with the digit 0 for any natural number n or not. Let us assume that 6 power n ends in 0 for a natural number n. Then 6 power n will be divisible by 5, as we have supposed that 6 power n ends in 0. So 6 power n will be divisible by 5, which further implies that 2 into 3 power n is divisible by 5. Here 2 into 3 is the factorization of 6. This further implies that the prime factorization of the number 6 power n has only two factors, 2 and 3, as shown here, and it does not contain 5. Here no 5 occurs. Also, fundamental theorem of arithmetic guarantees that every composite number has its unique prime factors. That is, a number which is composite has unique factorization apart from the order in which they occur. So there will be no other factors, prime factors, in factorization of 6 power n. Hence 6 power n is not divisible by 5, as it does not contain 5 as its factor. There is no 5. So this entire number will not be divisible by 5. Therefore, our assumption that 6 power n ends in 0 is wrong, as we have earlier supposed that 6 power n ends in 0. But here we conclude that 6 power n do not ends in 0, because there is no prime factor 5 in the factorization of 6 power n. So we conclude that there is no natural number n for which 6 power n ends in 0. Come to the question number 6 of exercise 1.2. Explain why 7 into 11 into 13 plus 13 and this are composite numbers. We know that a composite number has more than 2 factors if these two numbers have more than 2 factors, then we will say that these are composite numbers. Here 7 into 11 into 13 plus 13 can be expressed as 13 bracket 7 into 11 plus 1. Here we have taken 13 as common. 7 into 11 is 77 plus 1 78, 13. This 78 can also be factorized like this, showing that this number has more than 2 factors, namely 1, as 1 is the factor of every number. 1, 2, 3, 13, 6, 26, 39, like this. Therefore, this is a composite number. Similarly, in second part, we will take 5 common. So, it becomes like this, is showing that it has more than 2 factors. The number 1, the number itself, the number 5, the number 1009, all are its factors, showing that it has more than 2 factors. Therefore, the given number is composite. Also, when a prime number is multiplied by another number, it changes into a composite number. So these are composite numbers. Thank you. In other videos, in the next videos, we will take problems of exercise 1.1 based on even and odd numbers. Thank you.